Hi guys, it's Mrs. Holmer, and I'm here with you to do a little bit of graph review. So if you think about it, are there any graphs that you've heard of before or used before? Hopefully you've heard of something like a bar graph or a line graph. Mr. Jacobs will definitely take you through some graphs this year, but today we're going to review some basic graphs that you should already know, and we're also going to bring in our variables that we've been learning about. You also this week have a homework assignment on the scientific method. It's due by Thursday. That's the day of our quiz this week. If you don't have access to Schoology at home, please feel free to let me know and I'll provide you with a paper copy of the assignment. So let's get started with our graphing review. So there's basic graphing etiquette. When you make a graph or when you're looking at a graph, there should be some things that are already there that make it easier for you to understand what it is you're looking at. And so there are four things. The first thing being the title. The title should be across the top of the graph, just like it is here. And it should tell you a little bit about what you're looking at. So this definitely looks like a graph about Elf the puppy and its weight. The second thing you're going to do is you're going to label the X and the Y axis. You can see here on the Y axis it's weight and it's telling me my units in kilograms. That's the next thing. And here is the X axis, it's the month, and they're both labeled with the units that we've decided to use. And then lastly, if you need to show the difference between a couple different graphs, so if there was Elf the puppy and another puppy, and we had two graphs here, you would also need a key somewhere to let us know which graph was which. So this is basic graph etiquette. Don't forget the title, the X and Y axis labels, and the units. Now, this is something really important. Whenever we do graphing, your independent variable goes on the bottom of the graph, the x-axis. So we've been talking about what is the independent variable. It's the one I change. It's the one I do in the beginning, and we've been talking about the I. So it'd be really nice if it was the axis, the y-axis, because an I makes the y-axis, right? But we're going to knock it down and we're going to make it the x-axis. So your independent variable, the I, gets knocked down and it's going to be on our x-axis. Don't mind my dog that's barking in the background. And so this is something really cool because if you have a graph of an experiment, you already know what their independent variable is, what that scientist decided to change or what they were testing, and because it's on the bottom of the graph. So here is a graph of the birthday of students by month, and you can see down across the bottom their independent variable, what they were trying to see if it mattered was the month of their birth. And then the dependent variable, remember that D for dependent. Now the D does have a backbone, so that helps us remember that's on the y-axis. The D for dependent is going to go on the side, and you're going to want to put your units there if needed, because remember that dependent variable is always something measured, something that we collect evidence, and so it usually has some type of unit. So include that in your graph. And so independent I, knock it down on the x-axis. Dependent D, that backbone is for the y-axis. There you go. So take a minute. We're going to answer some of these questions and you're going to record the answers on your notes. So I'll give you a minute to go ahead and do that. So in this graph, the favorite type of music, notice real quick that they didn't have a title. Yeah, that's not good. So the first question says, what is the independent variable? So I knock it down. The independent variable is on the x-axis. Their independent variable is the flavor. D, dependent variable, that backbone for the D, that's going to be the number of students. And what's missing, like I said, right away I noticed there's no title to this graph. That's what's missing. So we want to know what this graph is about. So they should have said like the favorite flavor of students or something to clue us in what we're looking at. I'll give you another minute to work on the next set of questions. So here you have a graph of temperature on the 1st of September. And so we go to the independent variable, and that's the time across the bottom. The dependent variable, of course, the D, that backbone of the D is our y-axis, and so that's going to be temperature. And they've noted our units for temperature here is degrees Celsius. And so there you're real quick. We know that this scientist they changed the time, and he wanted to see if that affected the temperature on September 1st. All right. Now, the last thing you need to know are the different types of graph and when you're going to have to use them. So you want to go to that part of the notes on the back and make sure you fill in some of the blanks. So these should be pretty familiar to you: a line graph, a bar graph, and a pie chart. And so we'll start with the line graph. A line graph is used to show a change in a data over time. And so whenever you have a line graph, time is always your independent variable. As the time changes, what happens to my whatever I'm studying? And so here you'll see their time is in weeks, and they're studying the growth, or the centimeters. I'm trying to figure out what that was, the centimeters of a plant. And so when you want to show change, use a line graph. If you want to compare, brand A. Hold on a second. Millie, come here, Millie. Okay, yeah, she's got to get quiet. Make something. But if you want to show, you want to compare two things like brand A and brand B, or you want to compare different months, or different flavor toppings. I don't know if you can hear me over the dogs. I'm so sorry. You want to use a bar graph to display that different types of data. So this is for comparing, a bar graph. And lastly, we have a pie chart. If you have a percent, like 100%, and you want to show what percent each category is of the whole, you're going to want to use a pie chart so that you can clearly see here how much of the favorite pizza toppings pepperoni represents. It's 40%. You can tell that it's bigger than the other varieties of pizza toppings. And so for a pie chart, you want to show the percent of a whole. It's used to show percentages. So here are the three graphs that we will normally see: line graph, bar chart, and pie chart. And you'll be expected to make these during labs. So if you need any help, please make sure you ask questions. So we're going to take just a minute, and I want you to read through questions 1 through 5, and we'll go over the answers here. Try to decide whether or not we want to use a line graph, a bar graph, or a pie chart. Remember, a line graph is used to show change over time. A bar graph is used to compare, and a pie chart is used to show percentages of a whole. And so give these a shot, and we'll check your work in just a minute. All right, number 1, you are organizing the change in population for sparrows from 1900 to 1999. Notice right away there's a time involved, so this will be a line graph. Number 2, you are graphing the change in temperature of water over a 24-hour period. Again, this is change. Change is represented by a line graph if it's over time, and so it's definitely over a time period. This is, again, a line graph. Number 3, you are organizing the percent of people in each department of a company. We're organizing the percentage, so we want to know of the 100%, what percent is each department. And so that's going to be best represented by a pie chart. Number 4, you are comparing the average height that 3 different balls bounce up when dropped from one fixed height. Now this is a comparison, ball A, ball B, ball C. And when we compare, we want to use a bar graph. So that would be B. All right. We got a couple more to go through. Number 5, you are graphing the different substances that make up a pizza by percentages. Again, a percent is a pie chart. We want to do percent of the whole. So number 5 would be a pie chart. Number 6, you are comparing the number of people in your class that own various types of animals. When you compare, you use a bar graph. That would be B. Number 7, you are graphing the change in speed of a roller coaster as it travels along the tracks over time. When you show change over time, you want to use a line graph, A. And lastly, you are graphing the change in the boiling point of water as you increase the concentration of salt, as we add more salt. All right, so we're graphing the change in the boiling point as we increase the concentration of salt. Now, this one is interesting because it is a line graph. Even though we're not doing time, we're doing increasing the concentration of salt. And so that one may be a little bit of a tricky one because time wasn't involved, but it's still, when you're graphing change, you always want to use a line graph. All right, well, that's all we have for graphing review. There will be some practice coming up, and we'll make sure that we all understand how to make and interpret all these graphs. Have a great day, guys.